Okay, the algorithm itself is on this next slide. I'm not going to ask you to write it down at the moment. We're just going to start off by doing the thing. And if we do the thing, it will become clearer. So we're going to skip through that for now and just get on to the example. That is what you've already copied down. Right, here we go. First thing we are going to do, step 1. Label the start vertex, and we are going to start at A with a 0 label. Where did the label go? In which box did the label go? Yeah, so that's the distance to A is 0. Okay, we know for absolute certainty the distance to A is 0. And that is the first node, vertex, whatever point, whatever you want to call it, we have labelled. So 1 goes in that box. You now say, that node rather, is permanently labelled. As soon as there's something on the top right, we call it permanently labelled, that node is sort of finished with. Where can we reach directly from that permanently labelled node? C or B. So what we do next is we put boxes in at C and B. Okay? Which you've already drawn in. Now, what is the shortest distance then to get from A to B? And you look at the 1, which is the label on A, plus the distance to B. So what does that 0 plus 6 make? 6. Now you don't know that that's the minimum. At the moment that's just a working out value, so it goes down there. There may be a better route we don't yet know about, so that's a working out value. And you do the same for C. Given that we can get to A in 0 distance, and A to C is 3, what is the working value we put on node C? 3. So that goes down the bottom. Now there are no other nodes we can reach from the last permanently labelled node. So we look at the working values we've now got, which is the 6 and the 3. Which of those is the minimum value? The 3. So that node, that 3 becomes a permanent label. And which node in our ordering, what number do we put that in our ordering? 2. It's the second one we've made permanent. So that goes in there. Now we repeat where we were last time. We've just labelled a node as being permanent. Where can we go directly from C? D or E. So we put boxes at D and E. Okay. How can we get to D, or what distance will it be to D? Given we can get to C in 3, and C to D is 5, what will our working value be at D? 8. And if we look at E, given that we can get to C, and we're only going from our last permanently labelled one, given we can get to C in 3, and C to E is 12, what working out value will we put in at E? 15. So yeah, 15 there, and we said the 8 down there. And we only did that from the node we last made permanent. Of all of our unpermanent nodes, which one has got the shortest working value? The one at B has 6, and that's smaller than anything else. So we now make the node B1 permanent. So we label it with its 6, and that is the third node that we have labelled. Once you label them permanent, that is a guaranteed shortest distance to that node from the start. We've just made B permanent. Where can we go directly from B? E, and only E. So, to get to E from B, it's going to be the 6 plus the 8. What is 6 plus 8? 14. And because that's better than our 15, we now put that 14 in after the 15. And what you'd normally do is just put a light line through the 15 and cross the 15 out. You now say, okay, I've gone everywhere I can. What is my lowest temporary working out value anywhere?
8.
Is the 8 on D. So I make that D a permanently labelled 8. And that was the fourth one that I have done. And then you do it again. Okay, I've just labelled one permanent. Where can I go directly from D? E or G. E will be the 8 plus the 3, which is 11, and that is better than the 14, so I will add that 11 to my working value and cross the 14 out. I could also get to G, and that will be the permanent 8 at D plus the 20, so that will be 28 going in there. Those are the only places I could go to directly from D. Of the labels, of the nodes which are not permanently labelled but have working values, what's the smallest working value? 11 at E. So E is now permanently labelled 11. And E, that is the fifth one I have labelled. So I've just finished labelling E. It's been made permanent. Where can I go directly from E? F or G. So to get my working value at F, it'll be the permanent 11 plus 5, which is 16. To go down to G, it'll be my permanent 11 plus 9, which is 20, which is better than the 28. So I will put the 20 in and cross out the 28. Those were the only places I could go to directly. Of the nodes that are not permanently labelled, which is the smallest working value? 16 at F. So F is permanently labelled 16, and that is the sixth node. Where can I go directly from F? G. So that's going to be my permanent 16 plus 2, which is 18, which is better than the current 20. So I'll put an 18 down as my working value. Of all my nodes which are not permanently labelled, well, there's only one G, which is the minimum. Well, it's got to be G's 18. I label G with an 18, and that is the seventh one I have labelled. Everything is now made permanent. I now know that the shortest route from A to G is a route of length 18. Then to work out how you got there, you'll look at it, and if you say, did I come from F? Well, G is 18, F has got a label of 16, the distance between them is 2. Is 18 take away 2, 16? Okay, then I came from G to F. If you want to say, did I come like from G to D? Did I come from D to G? G's labelled 18, D's labelled 8. That's not 20 in between them. You didn't come down the DG route. So you backtrack. We're at F. Where did I come from F? E. And the labels either side of F and E is a 16 and an 11, and that has a gap of 5. Where did I come from E? How did I arrive at E? From where? D. Well, 11 take away 8 is the 3 that's on that DE arc. So, yeah, where did I come to from D? C, and from C to A. So you can backtrack. What you look at is if the permanent labels either end of an arc, if you do a taking away with those and they equal the length of the arc, that's the route you came. So you then backtrack and you find out where you came. Okay? And that is Dijkstra's algorithm. Okay? Oops, sorry, go back a bit. Don't know what all those noises are there for. So that's our shortest route, and that is Dijkstra's algorithm. Okay? It's fairly straightforward. Things where it won't work if you have negative weights, and it can't be used for finding longest routes, but there are ways around that. Anyway, that is Dijkstra's algorithm. So what I wanted you to do now is go back to the algorithm itself, show you the algorithm the way it's formally written, and I want you to either write this down or make your own notes about what you did. This goes over 2 slides. There's that slide, and there's also that slide. So I'm going to leave it on the first one for a bit. Either write that down or write it down however you want. Does anybody want to check over anything? Or in a minute, if anybody writes something down and wants to check it with me, I'll do that. I'm going to stop recording there for a bit.